G'day, I'm Neil and my handle is Wiley11. I'm just going to put my disclaimer here. Whatever I do and say on these videos is well-intentioned and well-meaning advice. I accept no liabilities whatsoever for any disclosures. If you take some advice or act on something that I'm saying on these videos, you do so entirely at your own risk. I'm doing it based on my experience. These videos are my attempt to give back to YouTube for the help and assistance that YouTube has given me. So once again, you follow along or follow advice from these videos entirely at your own risk. Okay, and if you're not happy to do that, click this off and off you go. Because this is purely my attempt to give back to YouTube, as I said, for the help and advice that I have received out of YouTube. So this is just my little attempt to give back. If you're happy to follow along at your own risk, buckle up, sit in, let's get into it. So the result of that was that I actually fixed the Z calibration, but I had two more problems. Now, most of the calibration was to do with switches and wiring, so that perhaps leads me into the next phase, which was the wiring issues that were wrong. So we had a problem with wires catching. There were two issues. One was we had a bent plug on the not the extruder, on the hotbed. So the plug for the hotbed was actually physically bent down, which meant that when the hotbed travelled on the Y, the plug hit the motor that drove the Y axis. And I'll give you some footage of that and how I've solved it. And the other problem I had was when I wired the motors up, I didn't realise that the driver wires for plugging into the motors were actually different lengths. And so there was one fairly long wire and one fairly short wire. And for your Z-axis motors, what you needed to do was put the long wire on the motor that's farthest away from your control board. And of course I put the short one on. So I had a problem. And to change those wires, you had to physically remove the motor. You couldn't just unplug it. You had to remove the motor, pull the wire off, put the correct wire on, and put the motors back on both of the motors. So it was a pain in the neck. It would have made more sense had I taken a bit more time and looked at the length of the wires first. So that's a big tip. Make sure you've got the correct wires going to the correct motors. And of course the X-axis motor, that needs to be a fairly long wire. It needs to be, because it goes up over the machine and down and over and around. So that one needs to be one of the longer wires altogether. The shortest wire is the one on the Z motor closest to the control board. And I didn't pay enough attention. I had them all over the place and I had to pull wires off and put them all back on the correct places. So we did that, and I guess I can show you that little bit of footage. So let's lead into that. Okay, so Neil from the future again. You guys are never going to believe this, but the Z1 and 2 wires are different lengths. Make sure you put the longer wire on the side with the motor that's on the, control board there, motor there, long wire, not short wire. Done work. I had to pull it all apart again. I had to start the job of putting the Z wires on twice. So it was just schmozzle. It was a cluster, if you see, I just couldn't believe it. I sat there, I thought, beauty, that job's done, tick, yep. Looked at the wires, I thought, crap. So, yeah, second gotcha on those Z motors is make sure you put the long wire on the side that's furthest away from the control board, not the short wire. Okay. Alright, so yeah, there's some gotchas in the build, you know, and I've done well. I think I've hit every one of them. I'm perfect score, gotcha. So hence the reason for this video, you know, like trying to save you guys a bit of time. So I'm just going to insert these two little clips. Neil from the future. I wish I'd done Neil from the future like 20 minutes ago before I put all this stuff back together and then worked out one wire was longer than the other. I didn't even look. I seriously didn't pay enough attention to it. And that's what it is. It's about paying attention to the job. And you would have worked it out straight away. Oh, one of these has got to be for the far motor. But I just made a decision, executive decision. I went, yep, no, that's good. Yep, that's going to go there. Yep, we're good. Yep. Nah, not so much. Right, so now what we need is we need the control board and the standoffs. So we need that to happen. I still have not attached the hotbed. I'm just dreading that I've forgotten something important there. And I think what I might do is I might do the hotbed. And then, yeah, I think I'll do the hotbed next. But I'm a long way into the build. I'm at the point where I've started running wires to see how everything's supposed to work. And of course, what I've done is I've come up with these issues about access to the plugs and whatever else. So it's a good idea to run your wire through the chassis and then plug it into the motor. And then you'll see immediately that one wire's longer or shorter than the other wire, and you'll work out immediately where things have got to go and where they've got to be run. I can tell you, I've hit every gotcha going, I think. There's a few I avoided by doing testing, but I broke a switch. I've actually used that same switch, and I've got to replace it when I've got a bit of time to run up the road and get a new switch. But for the moment, I've tested the switch, and it still works. So it's not holding me up. I'm just going to use what I've got, and when I get a bit of money together, I'll run up the road and get that switch. But yeah, I'm going good. Righto, back to it. Right, so I thought I had some footage of me fixing the Z motor stuff, but it's gone the way of the dodo by the look of it. I've lost some footage. I'm pretty sure it's around. It's just that there's so much footage. There's over 100 hours of footage in there to go through. All right, so look, the wiring cock-ups, there were a couple. There was no fuse anywhere on the system, and other than the 240 volt power box has a fuse built into that, there's no other fuses anywhere. So I decided to add fuses. I did some tests over how many amps were being drawn through the system, through the heat things, and my initial guess was that it was quite high amps. That was completely wrong. It's 15 volts, but it's low amps. So I think there's a 30 volt output from the box, DC output, which the board splits into two 15 volt, or they might actually be 30 volts, I can't remember now. But the amps are very low. There's less than 2 amps going through those lines, because they're not rated for more than, given the thickness of the wire that's there, it is heat shrouded, but they're not rated for high amp. So I think it was 5 amp wire from memory. Don't quote me, it could be wrong. But I've got two 30 amp fuses in there at the moment, and that's miles too high. And what I need to do is I'm going to drop them down to 10 amp fuses, because I have them. So I'll just find those and drop a couple of 10 amp fuses in there. Now the reason I want to do that is to make sure that if something jams or whatever, that the fuse is going to blow, because if you get high amps going through that line, things are going to melt, and you don't want things melting. So on the two power wires, the one going to the hotbed and the one going to the extruder, each of those lines has a fuse on it protecting it. Now the other thing about the wiring that I didn't like was that there was no requirement to separate the data wires that drive the stepper motors and the fans, the low voltage, from the 30 volt wires that drive the hotbed. So what I've done is I've isolated the high voltage wires in their own line, and I've put the fiberglass shroud over the high voltage, on top of the fact that they're shielded wires. I've put my own fiberglass shield over the top of that fiberglass mat shield, shielding sheath right over the top of all of that. So anything that's got any decent kind of voltage, 30 volts or 15 volts, whatever, anything that's not just a 5 volt or even 12 volt, it's shielded. It's shielded and it's separate. So I'm going to just do a quick walk around with the camera and show you that right now. Right, so the way I've solved this is that this plug was actually bent down, and I actually used a bit of brute force and bent it back up. So now it clears. So that's an issue dealt with. I'm going to continue with the build. I'm going to put this plate back on the way it was, so you don't have to reorient it. All you need to do is if your plug is down, just bend it up, which is what I've done. And it must have been bent in transit, I think, because I can't imagine why it would be bent. But anyway, there we are. Right, so what I'm going to do really quickly is show you the shielding. So this is the shielded wire. And you can see that it goes up around the top and down, right down here into the extruder. So there it is, down into, this is the one that goes down onto the extruder at the bottom. And then there's another one that's going this way, which is shielded all the way down to the hotbed. So that one there is shielded. And that joins up with this. And now what was happening was these wires were all tangling at the back and catching, and the way I solved that is I got them up in the air with a couple of rubber bands just to hold them up high so they don't actually jam and catch on any of these moving components here. So it was a simple solution, just use a rubber band to hold them up nice and high. And they go through the bracket. Here's the fuse box completed with the fuses in it. All of this wiring needs to be tidied up and put away so that it's not exposed. But that's a job for another day. At the moment everything's working, and I'm just going to do that when I've got time. So the jobs that still need to be done is this needs to be tidied up, and this power box needs its own isolation switch. So from this 240 volt line, which is this one, this needs to get tagged and put through its own isolation switch, which I'm going to mount up here, and that's going to be the end of the design modification. So I'm going to add a 240 volt switch there. I'm going to bring all the wiring up to the isolator. So if I've got to hit the button to stop everything, I can just do that and the switch is done. So that's it for the wiring. We're done. We're not going to say anything more about it. Just while we're up here real quick, I want to put a quick mention to these calibrating bubbles. So they calibrate for level for me. So I've got one there, one down in there. So as you can see, system's level and system's level. I know immediately that when I've got it in, it's mounted. I actually made this this little piece of laminated leftover cupboard board into the base for the printer, because it fits on it nicely and it gives it a home on the end of the bench. So the bench has been extended, as you can see, about I don't know what that is in the old money, but it's about 6 inches or 10 millimeters, 10 centimeters over the end of the bench, so that the printer and everything belonging to the printer can sit on the end of my bench quite happily, and it's in easy reach of my workspace. There's the printer, there's the workspace, and life's good. I've got the battery flashing at me. It tells me it's about to run out of battery. Everything for the printer can live here. It's all in its own little area. I've got my actual printer up here. This is my normal printer. It sits up the top there, and now my 3D printer sits there. And I can work sort of around here. It gets a bit messy sometimes, but I clean up real quick. Over here we've got my NGEMs. This is my PCBs for the NGEMs that have come in. First iteration of my design. I hope to God I've got it right. Done a lot of testing, so I hope I haven't made any mistakes with it. And of course my work area is a complete mess at the moment too. Everything's a mess. It needs a good clean up. Audio. Here's the NGEM still working. Look, there it is. Take my hand off, put my hand on, there it is. NGEM works. Righto. Let's keep going. Just got to keep moving forwards. That's all you can do. I like this engine. It's a really good design. Just when it gets dark enough, look. If it gets in enough shadow, it'll come on. If it gets out of shadow, that's just me moving my shadow into and out of that area. And when it comes on full, it stays on. And you can see it's a pulsing light. Okay, thanks for that. Right, so the final real problem that we had was with the extruder jamming, and we've got some footage now to just talk you through that. But what it ended up being was that the mount bolt for the fan with the yellow thing on the bottom of it at the front of the caddy went so far through the back that it actually hit the tensioner bracket for the extruder, the PLA feeder, and it couldn't move, it couldn't flex, so it was jammed, and the PLA stopped flowing, and it all jammed, and it caused a whole problem with ripping through things and doing things really badly. So that was a fairly significant problem. With a simple solution, all it required was we bent the plate at the front of the caddy. We just bent it out about 2 mil so that the tensioner had room to move up and down. That was all that was required. It also meant that that fan and its nozzle, it got a better angle into the extruder. By bending that plate forward, it just changed that fan a little bit, and it actually made it perform a bit better. So it was a simple problem, but it was a significant problem, and that required solving. And that really, apart from the walk around video at the very end of this bloopers reel. So let's just do this situation with the extruder jamming and show you what the cause of that was. So what's going on? Trying to do a print job. The problem is this filament is not going through the system. Now I fudged the operation to make this happen. You can see that the Z-axis has some issues, because you can see that it's actually dragging its ass around the plate. The X-axis switch is in the wrong position. See, that's not. Yeah, I've got to kill this job. Hang on. I don't know how to kill the job. Configuration. Oh, there's one way to kill it. There we go. Job's killed. I'm going to turn it back on because I don't want it to print, but I do want those fans on. Okay, so we're up on the menu. I'm going to go here and I'm going to go position. And I want to go home all. Look where it thinks home is. And that's because that X position switch there, right there, is in the wrong spot. That limiting switch needs to come over. Now there's a couple of good things about what my setup is. First of all, I can really quickly check for level on everything. It's easy to do. You can see it's gone out of level slightly when it started operating. Just a bit. That one there is perfect. That one there, not so perfect anymore. So I've got a couple of issues with the way it operates. I worked out that if you chuck your file on your G-code file on an SD card and you chuck it in there, in the slot, you can actually then use this menu up here to actually get it printing. And you don't have to worry about anything else. Now you can see that everything's cooling down quite nicely. You've got to leave your fans on, you know, like you can't just shut everything off and then turn everything off. You've got to have your fans on so you don't burn up your extruders and you don't burn up your hotbed. You don't kill them. Now what I didn't do then was I didn't look at the draw on the current. So that was a bit of an issue, but we'll do that in a minute. But I want to sort out how to get this filament loaded in the Tronxy. Got to be a way to load the filament in without having to take the fan off every time you do it. Now I think it has something to do with this screw on the top. So I can't see it very well, but see that screw on the top there? The filament goes into that hole there. But I think you've got to let that screw there off, pull that up and then load your filament and then push that back in. I'm about to find out anyway. Righto. Okay, so what I've done, just quickly, so I've taken a set of verniers, upside down and back to front for you guys, I know, but I'll put them on this one. And you can see it's about a 1.5 mil. I'll put them on this one. It's 1.54 mil. So the filament they've provided is the same as the filament I've got that I've bought. But I'm going to try it with their filament. Let's go again. Got to be some reason that that is not doing the job. Bring you guys over this way a bit. Should be able to see what's going on there. I'll just use this filament, put it up over the top again, down through there. Righto, so that's that. Heading up to print file again. I'm going to use their filament Let's see if we can get this to go through. Now I haven't adjusted this from when they sent it to me, right? So the manufacturer preset all this. I've just got their cooling fan hanging over here, hanging out. It's not actually doing anything, so it's fine. Probably doesn't know it's got a second cooling fan, I don't know. It's definitely not using it. Things are heating up. But this extruder is not working the way it's supposed to. See it, purple stuff. Push it down. It hits the point. There's an adjusting screw here to adjust tension. And what I've done is I've backed this tension right off. But I can't push that down at all. So if I tension it right up, I wonder, is that what you're supposed to do? The more you tension it, it's as tight as it goes. Let's see whether that works. I've no idea what that's doing to this guide over here on the right. I think it's pushing against that guide. That's as tight as that goes. Doesn't go any tighter. We'll see if it pulls that through. The two extruders, the hotbed's at 50 degrees, which it is, and the extruder's just heating up. Here we go. Let's see what happens. It's on its tightest setting. Yeah, you can see what's going on. That stepper mode is working, but as soon as I try to feed through that, nothing happens. This has got flies on it right here. We're gonna stop the job again. All I'm doing there is I'm making holes in the bed. Just turning everything back on to make sure it cools down properly. Starting to dig holes in the bed. I've got to get some of this tape. I'm going to have to pull this extruder apart. I don't know what the story is with this, but it's not right. Whatever's going on with it, I don't understand. But it's definitely not right. So we're going to pull that apart and we're going to have a look. I'll wait till everything cools down, we'll come back to this. So what I've done, folks, is I took that fan off so that I can see the mechanism. With the filament coming down, which you can just see comes down into there. So what I'm going to do is I'll see if I can get this thing to work by pushing it down with my fingers into that. Now I've adjusted this screw here down a bit tighter. It was the only way it could go. It was as loose as buggery. So what I did was I adjusted it down tighter. But see, it has to pick this filament up, and it hasn't done that yet. So that's what we're endeavouring to make happen, is to get that filament to pick up. And what we'll do is we'll put some tests on our ammeter while it's working. We'll see what our current draw is on that. Rightio. That stepper motor is not picking this filament up. Well, it is now. I'm going to adjust that on the fly, see if we can get it to... There's something really wrong with this. Okay, I'm going to cancel the job and I'm going to try it with the purple filament. As you can see, this bolt has gone right through and it's jammed this adjustment lever, and it's apparent in the video, but I didn't realise at the time I was recording that this was the problem, because I didn't realise, as you can see, it's bent this out ever so slightly, and it's hard up against this, which is horrible design, absolutely horrible. And to fix this problem, all I have done is I've bent this yellow plate out a little bit. Right, I've bent it away from the lever so that there's about a 2mm gap there, and now this adjustment lever travels up and down freely. But that was so hard, it had actually made a hole in this adjustment lever. So that was the problem with the, and I'm calling it extruder, it's actually the feeder. As you can see, there's the feeder goes through, and this actually adjusts the tension on that feeder drive wheel, and that was the whole problem. Where am I? Where's my recorder? Okay, so what I want to do now is move away from all of the individual issues and just do a general walk around with you, highlighting what I didn't like, and that video is coming up, and then we'll come back and just wrap this up. Right, so I'm going to do a quick walk around of this build, point out the things I had difficulty with. Let's start at the front and work our way around, and I'll also point out what I like and dislike. Let's start with dislike. Dislike this arrangement down here, the Z-axis trigger. Don't like that at all. Don't like the way this sits into nothing. So at the top here, you can see that's just suspended in that hole. It's not doing anything. There should be a bearing to hold that proud. Also on this side, same thing. There's nothing to hold it. It's just sitting in the hole. Don't like that there's no termination Y switch here. Should be a terminating switch there. Don't like that there's no terminating Z switch here. Don't like the X with the travel. Look where the hot end is. See if I can show you from the back. Hot bed finishes here, hot end over here. Not good. Now same in the Y direction. it goes past, just past. So you could be printing in this area here. You'd be dropping hot stuff all across your wires. Don't like this arrangement with my wires. I don't know how I've managed to do this, but I've somehow managed to cock this up. See here, no fuse, so I've added this. By adding this fuse, I've actually managed to cock this up a bit. I've put this brake in the wrong place. I should have put it further back here. But that said, I should be able to pull this up a bit higher. Not sure how I achieve that yet, but I should be able to keep it up so that this, when it comes back, tracks like that. And that wire isn't going to catch on anything. I'll have to have a look at that and see how I can make that stay proud like that. Maybe I'll put a cable tie around those, nip them up to the top so that they stay up. I've added these fuses. Didn't like the way this was assembled. I had to disassemble this and reassemble it. I didn't like the way this was set up. I had to disassemble it, and I've added washers to the whole build. So every one of these bolts, focus, has got a washer. Every single one. Right. So every time I've used a bolt, I put washers in. Now I've added washers to this part of the build. I've moved the spring washers to the outside to keep tension at the outer point, and you'll now see that the belt tracks inside those two washers as a guide. See that? Excuse me. Final comment. I've added a hole here to put this this arrangement together. This is only temporary. I've got to find a better arrangement than this, but I've got a hole added up the top here. I do not like the power. It's coming in here. There's nothing to stop this from twisting and turning. You know, as this cable, you can see that whole cable moves as the plug moves. There's no safety cutout on this power supply, and as such it would never pass Australian OH&S. So I'm going to mount a box here with a 240 switch. I'll run the wiring to the 240 and then run it out of the box off to power with its own switch, its own isolation switch up here. So that what we want to do is we want to make sure that we have an isolation switch that it'll sit out here somewhere, that you can push the switch and turn everything off. So that's got to be added to the job. Have a look at the wiring over here. It's a butcher's mess. It's a horrible mess. But that said, it's done. Everything is situated. I don't like that the board's exposed. I would like to get myself a cover that I could make to put over that board and give that some protection. So we might build a cover to sort of tidy all this area up. Okay, so it'll all get tidied up. But it's ready for its sea trials. It's wired up. There's no reason we couldn't plug it in and use it, other than the fact that we are OH&S non-compliant because we have no safety cutout switch for the 240. There is a fuse inside the box. I saw the fuse. I don't know if it's a 12 volt or a 240 volt fuse. I didn't look that hard. But it's pretty cheap and nasty. It's a, as you can see, $250 amp. It's got a 10 amp wire, so this is a 10 amp plug. Its rating is 10 amps. And it's rated, so it's all stamped and rated, but it's really not wired correctly for Australian OH&S. You can also see that the power supply has its own idiosyncrasies, and it had some fiddling to do with this cover plate here. You know, we just had things that I've added. I added this shroud to run this 12 volt line The reason I decided to do that was that I never ever run 12 volt and 5 volt in the same conduit, same shroud. So I put my own wiring together. You can see already that I've got a tear in the harness here. So that's getting, you know, that's torn there. And all I've been doing is this. Now, you might be able to see that there's already a score in this thing, and that's because this hotbed is not 100% level. So I've got to calibrate this for level. I've calibrated this. It's kind of level, but it's not. Everything requires calibration now. So I need to find, the printer's going to live over here, but this is not level. Right? So I've got to find myself a sheet of wood that's going to go in, see here? It's going to slot into this and hold this printer. So all of this area here is for the printer. So there's everything there. That's the thing for holding the PLA. Comes up over the top of the printer, and the rest of it will sit like this. You know, I'm just going to put the printer where I want it. Stay. I'm putting this printer where I want it. It's going to hit the camera, isn't it? It's going to turn around. Its weight is probably about 12 kilograms all told. The printer will sit there. That will be its permanent home. And I'll get a piece of wood for that to sit on. You can tell. Let me see if I can show you. It's not level. She's cattywampus on that, because this was never made to be anything other than storage. Now it's got to hold that printer. So I need to level that up, and then I've got to decide whether I'll sit it this way or sit it with the front out this way on its supports. And once it's out there, I can shim it and level it. Get it all the base will be completely level to gravity, to the earth, and then I won't have to worry about vibration or anything else. So I've got to get a piece of timber for under there, and I've got to get the electrician out. But other than that, I've got to just sort this mess out, tidy that up a bit, and we're done. We've finished the job. Now the final thing about this build was, I don't know that there was terribly much that the manufacturer put together for me that actually worked the way it was intended. For example, the Y drive sprocket, you know, like it went the belt on the front, I don't know what to call it, the bracket that held the belt that goes around like that. It was completely wrong. It was assembled for you, and all you were meant to do was put it on. But it was just horribly assembled, and it was missing some washers that, well, it had the spring washers in the wrong place. And what was going on was the spring washers were actually disappearing in bushings instead of doing the job of holding things proud. They're not designed to hold things proud, they're designed to hold things in tension, and they need a flat surface. And they were assembled inside the bushing, and they weren't proud, and the bearing was doing these ones and moving like this, and everything was cattywampus, and it was all terrible. And what I ended up doing was adding washers to the build. I actually went and bought some more washers, and so that the bearing was supported proud, and then the spring washer was on the outside rather than on the inside of the bracket. I moved them all the way to the outside of the build, the bracket, so that they were against flat surfaces rather than against beveled edges and disappearing in. So the bearing is now tracking truly. It is tracking horizontally by adding a couple of washers. It was a simple fix, but it was an important one, because that's the sort of thing that wears out drive belts and causes problems. Now, the other thing is the complete lack of fuses and the complete lack of an isolation switch. Now, those things were a problem. And the control box at the top, the actual control box, was completely cattywampus. It was put together for you, but it was horribly put together. And I pulled that completely apart, and I added washers to pack out the boards so that they weren't under any tension, any twist tension. When they were put in, they're actually put in all level, so they're straight up and down. And I might have a bit of footage where I redid the board, but you can see that in the video anyway. But what I recommend you do is, if you've got the kit and anything's assembled by and indeed the hot end, the caddy, it was all assembled inside the caddy, but when you screwed your fan on, it came in and it had immediately jammed up the tensioner. So everything that was assembled by the manufacturer needed revision. Okay, so that's a big one. Don't just accept that the manufacturer put it together the right way. They didn't. You need to go in and look at everything the manufacturer has provided and put together, and make sure that there's things in the right places and that there's washers on things, and it's just a little bit of extra care. Now, I've been at this build for probably, I think I got it in June, and I think it was September before I was using it 100% correctly. And that's over time. I've been using it and sorting things out as I've been using it. Doing small runs, it's not apparent that you've got a problem. It's when you do a large print that uses the whole of the plate that the problems have become apparent, that you're a little bit, like you've only got to be half a mil out of level, and your job won't stick to the hot plate. It'll start dragging PLA, and you end up with a big molten squashy blob of PLA somewhere. And if you've just assumed it's right and you don't watch it like a hawk to start, you can end up with a great big blob of PLA. And there's nothing that says that, it's gone cattywampus. The system doesn't know. It'll just keep moving the head and pushing hot PLA through. So you end up with a golf ball sized blob of it, which you can recycle, but you'd rather get your job. Okay, so don't take anything for granted. Read every document you get like a hawk. If I'd read the documentation, I would have saved myself hours. If you want to see more of the build, there's actually parts 1, 2, 3, and 4 going up to YouTube. This is part 0, which is basically everything you shouldn't do and what you need to look out for. So that's it. That's all the good, the bad, and the ugly with this build of the Prusa Tronxy i3 3D printer. And I wish you every success with your own build. Now, I want you to make good decisions and do good things. If you don't think you can do it, have a crack anyway. Get into it and keep on swinging. If you just don't give up, you'll get there. Support my company, nightglowmanufacturing.com. If you buy my product, I can keep putting these videos up. I can keep employing local people, and I can keep things that would otherwise have gone into landfill out of landfill. And by using my product, you're saving the planet. By supporting these videos and sharing them, you're helping somebody somewhere. So like and subscribe to my channel, my videos, and again, just make good decisions and be good. Just do the right thing. That's all it is. Have a bit of a think about it, and if there's a right one or a wrong way, go the right way. It's that simple. Righto. Kia. Thanks for watching.